Hello, in this video we'll be doing a practice problem involving limiting and excess reactants. So we're given this here question. So if 3.4 grams of sodium sulfate was reacted with 4.5 grams of barium nitrate, how many grams of barium sulfate would be theoretically produced? And this is often how you'll see these limiting and excess reactant questions phrased, because ultimately what we're looking for is the theoretical yield. We're looking for how much of our solid can we theoretically produce with these amounts of these reactants. And that's going to be dictated by the limiting reactant. So there's some stoichiometry that we have to do involving these amounts, because ultimately we want to get to grams of barium sulfate. And we're going to need to figure out which of these two reactants is the limiting reactant, because however much we can produce is determined by the limiting reactant. So we're just going to take this one step at a time. So since the sodium sulfate's mentioned first, I think it would be okay to start with that. So what you want to do is you want to start with your given amount of sodium sulfate, which I'm going to abbreviate as SS. So we'll start here. So we have 3.40 grams of SS, sodium sulfate. And what you want to do now is convert from grams to moles of sodium sulfate. And to do that, pause for a second and think how we can get from grams of sodium sulfate to moles. And of course we're going to use the molar mass. So we're going to use the molar mass of sodium sulfate to get to moles from grams. So there we go. So we're going to take the molar mass, which is 142.04 grams, and we'll put 1 mole on top, since ultimately we're going to need to use a mole-to-mole ratio to get towards barium sulfate, and that's going to be our next step. So here we've used our mole-to-mole ratio, so up here we have 1 mole of sodium sulfate for every 1 mole of barium sulfate. So here they have a 1-to-1 molar ratio. They won't always have a 1-to-1 molar ratio, so always refer back to the actual reaction above for those times where there won't be a 1-to-1 molar ratio. So now that we've converted into moles of barium sulfate, which I've abbreviated as BS, we can now use the molar mass of barium sulfate to get towards grams. So we'll use the molar mass to convert to grams of barium sulfate, which is what we want our final answer to be. And this will be the last step of our stoichiometry. So if you want to pause and take a quick second to maybe write that out on your own, go right ahead. So if you got this, this is the absolutely correct way to do this. So we've got the molar mass here with grams on top, and this is the last step of our stoichiometry. So now go ahead, pause the video, do this the whole way through, get your answer, and then I'll write the answer at the end and you can compare them to see if they're similar. Okay, so you should get something around 5.59. Okay? So now that we've got that part solved for, we have to go through and do the other one, because we will need to compare the answers we get right here for both reactants. Whichever one's smaller is going to be our limiting reactant. So I'm going to go ahead and let you pause the video and repeat this process that we did here, but instead of sodium sulfate, we'll use barium nitrate, our other reactant. So go ahead, pause the video, run through it, see what answer you get, and then compare it with mine after you're done, and you can replay the video. Okay, so once you run through the barium nitrate problem, you'll do the exact same thing where you take the molar mass of barium nitrate to convert into moles. Then you'll do your mole-to-mole ratio to get to moles of barium sulfate. Then you'll use the molar mass of barium sulfate to convert into grams of barium sulfate. So now is the time where we can assign limiting and excess reactants. So take a look at both of these numbers and see which one is smaller. So because this one here is smaller, we'll call this the limiting reactant, which I'll abbreviate as LR. So this number here of 4.02, because it comes from the limiting reactant, which is barium nitrate, 4.02 grams is the answer to the question of how many grams of barium sulfate would be theoretically produced. Remember how I said it's determined by the limiting reactant? Well, since this is from barium nitrate, the theoretical amount of barium sulfate that we can produce is 4.02 grams, because that's dictated from the limiting reactant. And the other number, the 5.59, because it's larger, is going to be the excess reactant. So that means sodium sulfate is going to be our excess reactant, which means some of the sodium sulfate will be used up in the reaction, but some will also be left over. Whereas barium nitrate, which is the limiting reactant, is going to be completely used up in the course of the reaction. So to answer the question, how many grams of barium sulfate would be theoretically produced, it would be 4.02 grams, which is coming from the limiting reactant. So I'm going to throw in the secondary question here, because this question could often accompany the regular limiting and excess reactant calculation question. So you might have like a part B slapped on that says something like, how much of the excess reactant, in this case sodium sulfate, is left over after this reaction takes place? So we know some sodium sulfate is going to be left over since it's the excess reactant. It's going to be in excess. But given the amounts we used in our reaction that we did just now, we can calculate exactly how much is going to be left over at the end. So it involves this sort of three-step process, and I'll walk you through each step of how to do this. So step one is going to involve how much excess did you start with. And just to clarify, we're looking for the grams of sodium sulfate that are left over. So how many grams do we start with? Well, if we go back up to the question, we'll see that we started with 3.4 grams. So no calculation necessary here. We'll just say 3.4 grams. And that satisfies that part of the question. So then step 2 asks, how much of the excess is used up? So we know that the limiting reactant and the excess reactant are going to interact with each other to produce our solid barium sulfate. So the limiting reactant is going to dictate how much of the excess reactant is used up. That might not make a whole lot of sense, but just kind of follow it. So what we're going to do in step 2 is we're going to start with how much of the limiting reactant we started with, use a mole-to-mole ratio to compare it to the excess reactant. And hopefully that makes more sense once you see the stoichiometry behind that. So to start off, we'll start with how much of the limiting we started with in step 2. So we have 4.5 grams of barium nitrate that we started with, and we're going to use the molar mass of barium nitrate to get that into moles. So next we'll use the mole-to-mole ratio to get to moles of sodium sulfate from moles of barium nitrate. And you'll get these numbers here from the balanced equation above. So for every 1 mole of barium nitrate, there's 1 mole of sodium sulfate. So in the final part of the stoichiometry, we're just going to use the molar mass of sodium sulfate to get into grams of sodium sulfate, which is what we want the sort of answer to be in. So go ahead, you can feel free to pause the video and run through the stoichiometry to get an answer at the end to compare to what I will put up. Okay, so your answer should be somewhere around 2.45 grams as your answer here. So step 3, our final step, is pretty straightforward. We're just going to subtract this number and this number. So if you remember, step 1 is how much of the excess we started with. Step 2 we use to find how much of the excess is used up. So it sort of logically follows that to find how much we have left over, we'll subtract our starting amount from our amount that's used up. And so the answer you get here should be 0.95. So this is your final answer for this second question. So how many grams of sodium sulfate is left over? 0.95 grams is left over. And again, that's where we take the starting amount and we subtract the amount that's used up, which we calculated using this stoichiometry here. So this has been sort of the example of the comprehensive limiting an excess reagent sample problem. If you have any questions, feel free to watch any part of this video over again. I know we went over a lot in this, and I hope this cleared up any confusion you might have had about how to tackle one of these problems.